Running equipment at a voltage that is plus 5% of its rating can introduce several potential problems. Firstly, overheating becomes a concern. Increased voltage causes higher current flow, and this, in turn, generates more heat in electrical equipment. Overheating can significantly shorten the lifespan of your equipment. It can also damage the insulation that protects wiring and other components, and it increases the risk of electrical fires. Secondly, reduced efficiency can occur. Overvoltage can lead to decreased efficiency in motors, compressors, and other equipment. When the voltage is too high, components may be forced to operate beyond their optimal voltage range, resulting in lower performance and higher energy consumption. Thirdly, increased wear and tear is another potential negative impact. Prolonged exposure to overvoltage can accelerate wear and tear on mechanical components. This can lead to premature failures, increased maintenance costs, and a reduction in the overall reliability of the equipment. Fourthly, damaged sensitive electronics needs to be considered. Some electronic devices, such as uninterruptible power supplies or UPS, are particularly sensitive to voltage fluctuations. Overvoltage can damage these devices or shorten their lifespan considerably. Fifthly, insulation failure is a risk. Excessive voltage can cause insulation to break down. This breakdown can lead to electrical shorts and significant equipment damage. Sixthly, HID ballast failure is another area of concern. HID, or high-intensity discharge, ballasts are designed to operate within a specific voltage range. Overvoltage can cause these ballasts to fail prematurely or significantly shorten their lifespan. Seventhly, transformer overloading becomes a factor, especially if the utility reduces the voltage of the transformer secondary. The transformer may become overloaded if the equipment's power consumption remains the same after the voltage reduction. It is generally not advisable to run equipment at plus 5% voltage for extended periods. Have the utility reduce the transformer voltage to an appropriate level, such as 480 volts, to avoid these potential negative effects. Closely monitor equipment performance to detect any signs of overheating, reduced efficiency, or other issues. Consider installing voltage regulators or surge protectors to protect sensitive equipment from voltage fluctuations. These devices help to maintain a stable voltage supply and can prevent damage from voltage spikes or surges. When dealing with electrical systems, always adhere to safety regulations and consult with qualified professionals to ensure the safe and reliable operation of your equipment. If you want to examine the effects in a more detailed sense, you need to consider the function of each device. For motors, a higher voltage than specified can lead to increased magnetic saturation in the core. This saturation can cause higher core losses, which contribute to overheating and reduced efficiency. The motor may also experience increased vibration and noise levels. For compressors, overvoltage can stress the motor and other components, potentially leading to premature failure. The compressor's efficiency may also decrease, resulting in higher energy consumption. HID ballasts are particularly susceptible to damage from overvoltage. These ballasts are designed to provide a specific voltage and current to the HID lamp. When the voltage is too high, the ballast can overheat and fail. The lamp itself may also be damaged, resulting in reduced light output or premature failure. Uninterruptible power supplies, or UPSs, are designed to provide a stable power supply to sensitive electronic equipment. Overvoltage can damage the UPS internal components, such as the rectifier, inverter, and batteries. This damage can reduce the UPS ability to provide backup power during a power outage. General electronic components, such as resistors, capacitors, and semiconductors, are also vulnerable to damage from overvoltage. Overvoltage can cause these components to overheat, fail, or degrade over time. This can lead to malfunctions or complete failure of the electronic device. When examining insulation, it is rated to withstand a certain voltage level. Overvoltage can exceed this level, causing the insulation to break down. This breakdown can lead to electrical shorts, ground faults, and potentially hazardous conditions. Consider the voltage tolerance of your equipment. Most electrical equipment is designed to operate within a certain voltage range. Check the equipment's nameplate or technical specifications to determine the allowable voltage range. If the voltage exceeds this range, take steps to correct the issue. Measure the voltage at various points in your electrical system. Use a calibrated voltmeter to measure the voltage at the transformer secondary, at the equipment terminals, and at other critical points. This will help you identify areas where the voltage is too high. Consult with the utility company to address voltage issues. If the voltage at the transformer secondary is consistently too high, contact the utility company and ask them to adjust the transformer taps. This will lower the voltage to an acceptable level. Install voltage regulators to stabilize the voltage. Voltage regulators can help to maintain a stable voltage supply to sensitive equipment. These devices automatically adjust the voltage to compensate for fluctuations in the incoming power. Use surge protectors to protect against voltage spikes. Surge protectors can help to protect equipment from voltage spikes caused by lightning strikes or other electrical disturbances. These devices divert excess voltage away from the equipment, preventing damage. Consider upgrading your electrical system if necessary. If your electrical system is old or outdated, it may not be able to handle the voltage demands of modern equipment. Consider upgrading your system to ensure that it can provide a stable and reliable power supply. Implement a regular maintenance program. Regular maintenance can help to identify and correct potential voltage issues before they cause problems. This includes inspecting wiring, connections, and equipment for signs of damage or wear. Train personnel on voltage safety. Ensure that personnel are trained on the dangers of overvoltage and the proper procedures for working with electrical equipment. This will help to prevent accidents and ensure the safe operation of your electrical system. Document all voltage measurements and corrective actions. Keep a record of all voltage measurements and corrective actions taken. This will help you track trends and identify potential problems before they become serious. Furthermore, understanding the technical aspects of voltage and its impact on electrical equipment is crucial for maintaining a safe and efficient electrical system. Voltage is the electrical potential difference between 2 points in a circuit. It is the driving force that causes current to flow through the circuit. Voltage is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amperes or amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. The relationship between voltage, current, and resistance is defined by Ohm's law, which states that voltage is equal to current times resistance, or volts equals amps times ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Power is equal to voltage times current, or watts equals volts times amps. Overvoltage can have a significant impact on the performance and lifespan of electrical equipment. When the voltage is too high, it can cause excessive current flow, overheating, and damage to components. Overvoltage can also reduce the efficiency of equipment and increase energy consumption. The amount of damage caused by overvoltage depends on several factors, including the magnitude of the overvoltage, the duration of the overvoltage, and the sensitivity of the equipment. Some equipment is more tolerant of overvoltage than others. Sensitive electronic devices, such as computers and medical equipment, are particularly vulnerable to damage from overvoltage. There are several ways to protect electrical equipment from overvoltage. One way is to use voltage regulators. Voltage regulators are devices that automatically adjust the voltage to compensate for fluctuations in the incoming power. This helps to maintain a stable voltage supply to sensitive equipment. Another way to protect against overvoltage is to use surge protectors. Surge protectors are devices that divert excess voltage away from the equipment, preventing damage. Surge protectors are typically used to protect against voltage spikes caused by lightning strikes or other electrical disturbances. It is also important to ensure that your electrical system is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect equipment from damage in the event of a short circuit or ground fault. Furthermore, the National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical systems. The NEC specifies the allowable voltage range for different types of equipment and provides requirements for overcurrent protection, grounding, and other safety measures. Adhering to the NEC is essential for ensuring the safe and reliable operation of your electrical system. When dealing with overvoltage, it is important to take a systematic approach to identify and correct the problem. The first step is to measure the voltage at various points in your electrical system to determine the extent of the overvoltage. The next step is to identify the cause of the overvoltage. Common causes of overvoltage include problems with the utility power supply, faulty equipment, and wiring errors. Once the cause of the overvoltage has been identified, take steps to correct the problem. This may involve adjusting the transformer taps, replacing faulty equipment, or correcting wiring errors. After the problem has been corrected, monitor the voltage to ensure that it remains within the allowable range. Regular maintenance and inspections can help to prevent overvoltage and other electrical problems. Also remember that electrical safety is paramount. Always follow safety precautions when working with electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Disconnect the power before working on any electrical equipment. If you are not qualified to work on electrical equipment, hire a qualified electrician. Addressing concerns about lowering the voltage to 480 volts instead of 500 volts, it is essential to understand the design parameters and tolerances of the equipment connected to the electrical system. While running equipment at exactly its rated voltage might seem ideal, electrical systems are designed to operate within a certain voltage band. The 480-volt system, for example, is intended to supply equipment rated for 460 volts because voltage drop occurs along the circuit conductors from the source to the load. Setting the transformer secondary to 480 volts takes this expected voltage drop into account. If the utility cannot reduce the voltage to 480 volts and must set it at 500 volts, it's critical to understand the reasoning behind their decision. There might be technical constraints related to the grid configuration or other factors influencing their ability to provide precisely 480 volts. However, this does not preclude the possibility of supplemental on-site voltage regulation to further fine-tune voltage levels as needed. When the utility sets the secondary voltage to 500 volts, the equipment will receive voltage levels above the nominal 460 volt rating. However, it is essential to consider the accepted tolerance range of electrical equipment. Motors and other devices are typically designed to withstand voltage variations of plus or minus 10% of their rated voltage. This means a 460-volt motor can operate safely within the range of 414 volts to 506 volts. However, operating at the upper end of this range for extended periods can still lead to the previously discussed issues such as overheating and reduced lifespan. The concern about operating HID ballasts, UPS systems, and other sensitive electronics at a higher voltage remains valid, since these devices may have tighter voltage tolerance ranges. Therefore, individual assessment of each piece of equipment's voltage tolerance and sensitivity becomes important. In situations where equipment is particularly sensitive to voltage variations or known to be intolerant of overvoltage, the installation of voltage regulators or constant voltage transformers may be necessary to ensure a stable and appropriate voltage supply. Furthermore, it is crucial to monitor the performance of all equipment connected to the electrical system. Regular inspections for signs of overheating, unusual noises, or decreased efficiency can help identify potential problems early on. If any issues arise, it is essential to address them promptly to prevent further damage or equipment failure. If the utility sets the transformer secondary voltage to 500 volts, perform a thorough assessment of all connected equipment's voltage tolerance, implement voltage regulation for sensitive devices, and closely monitor system performance. This approach ensures that the electrical system operates safely and efficiently while minimizing the risk of overvoltage-related issues. If the voltage is measured at the VFD at 521 volts and the VFD were originally set for 460 volts and the high limit was raised to 480 volts with a 10% allowance, this means the VFD were set to tolerate a maximum of 528 volts. This indicates a problem. The utility reducing the transformer to 500 volts may not resolve the issue. A 480-volt system can operate between 432 volts and 528 volts, which is 10% above or below the nominal rating. Electrical power distribution systems are engineered to deliver voltage within an acceptable range at every point in the system. A 480-volt nominal system is designed to accommodate variations in voltage due to load changes and other factors while keeping the voltage supplied to equipment within specified limits. The American National Standards Institute, or ANSI, Standards 84.1 defines voltage ranges for electrical power systems. Range A is the normal operating voltage range, while Range B allows for occasional voltage excursions outside of Range A. For a 480-volt system, Range A typically spans from 440 volts to 480 volts, while Range B may extend to 504 volts. Electrical equipment is designed to operate within these voltage ranges without experiencing adverse effects. However, sustained operation outside of these ranges can lead to problems. The 480-volt system employs step-down transformers to reduce the medium voltage distribution level to a utilization level suitable for powering industrial equipment, motors, and lighting systems. The transformers are designed to provide a nominal secondary voltage of 480 volts when the primary voltage is within a specified range. The transformer's tap settings can be adjusted to compensate for variations in the primary voltage and maintain the desired secondary voltage. Electrical panels and distribution boards further divide the 480-volt supply into branch circuits that feed individual loads. These panels contain circuit breakers or fuses that protect the branch circuits from overcurrents and short circuits. The branch circuits are wired using appropriately sized conductors to minimize voltage drop and ensure that equipment receives the required voltage. Motors are one of the most common types of electrical loads in industrial facilities. They convert electrical energy into mechanical energy to drive pumps, fans, compressors, and other machinery. Motors are designed to operate within a specific voltage range, typically plus or minus 10% of the rated voltage. Operating a motor outside of this voltage range can lead to reduced performance, overheating, and premature failure. Lighting systems consume a significant portion of the electrical energy in many facilities. Lighting systems can include incandescent lamps, fluorescent lamps, high-intensity discharge lamps, and light-emitting diode lamps. Each type of lighting system has its own voltage requirements and operating characteristics. Electronic devices are becoming increasingly prevalent in industrial facilities. These devices include computers, programmable logic controllers, variable frequency drives, and other types of electronic equipment. Electronic devices are sensitive to voltage variations and require a stable and reliable power supply. Voltage regulators and uninterruptible power supplies are often used to protect electronic devices from voltage fluctuations and power outages. Proper grounding is essential for ensuring the safe and reliable operation of a 480-volt system. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect equipment from damage in the event of a ground fault. The 480-volt system must be grounded in accordance with the requirements of the National Electrical Code.